Myself, P. Reddy Prasad, Associate Professor, Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss Engineering Chemistry Syllabus, Electrochemistry and Corrosion, Module 1. The topic is Electrochemical and Electrolytic Cells. In this talk, the content is Introduction of Electrochemistry, Electrolytic Cell and Electrochemical Cell, and what are the differences of electrolytic and electrochemical cell. Now we are going to discuss the introduction of electrochemistry. Electrochemistry is a branch of chemistry. It can deals with the transformation of electrical energy into chemical energy or chemical energy into electrical energy. This is the conversion in between the electrical energy to chemical energy to electrical energy. So in these reactions, in these electrochemical reactions, it can involve electrons. That's why the electron transfer is involved in the reaction. Maybe that is oxidation reduction reaction or redox reactions. Usually, batteries and fuel cells convert chemical energy into electrical energy and are used on a large scale in various instruments and devices. So, majority of the renewable resources are working on renewable devices are working on this electrochemistry principle. Chemical energy is converted to electrical energy. So that's the reason large scale of industries or various instruments or devices, it's working on this principle. The reactions carried out electrochemically can be energy efficient and less polluting. So that's the reason nowadays the people are looking for electrochemistry broadly. First of all, the Galvani late 17th century, he was observed a frog's leg twitched when exposed to the current. Then after Volta, early 18th century, he realized the current flow through the fluid of body and it can identify that current. And Volta, in addition, he invented the first battery by connecting multiple electrochemical cells. So this is the introduction of electrochemistry. Now we are going to discuss electrochemistry. We know that it is a branch of chemistry which deals with the interconversion of electrical energy and chemical energy. And these interconversions are two types. So majorly, the conversion is happened from electrical energy into chemical energy is called electrolytic cells. And conversion of chemical energy into electrical energy is called electrochemical cells. So the interconversion is happened two types in the electrochemistry. The conversion of electrical energy into chemical energy, it is called electrolytic cell. The conversion of chemical energy into electrical energy is called electrochemical cells. So electrolytic cell means, so the utilization of electrical energy, we are going to discuss chemical compound. We are going to identify the chemical reactions of the compound. So that is chemical energy. So in the electrochemical cells, the chemical energy utilizes the chemical energy and converted to electrical energy. So this is the differences in between the electrochemical cells and electrolytic cells. In the electrolytic cell, electrical energy is converted to chemical energy. In the electrochemical cells, the chemical energy is converted to electrical energy. Now, electrolytic cell. The one of the cell that is electrolytic cell. Electrolytic cells are used for electrolysis of certain compounds, either inorganic compound, either organic compound, or so many compounds. If a substance, inorganic substance, we are going to identify, quantified using of these electrolytic cells. In the electrolytic cell, usually the electrical energy from an external source is converted to chemical energy. It is a non-spontaneous oxidation reduction reaction is happening. Non-spontaneous oxidation and a redox reaction is involved to the reaction. It is a non-spontaneous reaction is involved in the electrolytic cell. What is redox reaction? Redox reaction is nothing but it is oxidation reduction reaction simultaneously involved in the reaction. Oxidation and reduction reaction is simultaneously involved in the electrochemical cell. That process is called as a redox reaction. In the electrolytic cell, there is important component is there. So electrode, these are the electrodes, and electrolytic solution, that is electrolytic solution, NaCl is the electrolytic solution. So battery, we are connected this two electrodes with battery because it's a required battery energy to electrolysis of NaCl. And these two electrodes they act as a anode and cathode. The two electrodes they act as a anode and cathode. So in the electrolytic cell, anode we are represented by positive sign. In the electrolytic cell, anode we are represented by positive. In the cathode, we are represented by negative sign. So cathode, it is a sign is a negative. These electrodes were connected with battery. So NaCl is the electrolytic cell. Electrolyte. This NaCl is dissociated into Na plus ions and Cl minus ions. That process is called as a electrolysis process. So when the electrolyte is going to dissociate it, is Na plus and Cl minus ions, that process is called as a electrolysis process. Through the electrolysis process, Na plus ions to move opposite sign of the electrode. Similarly, the Cl minus ions to move opposite sign of the electrode. So that's why chloride ions to move positive sign of anode at the anode, and Na plus ions to move at cathodic side because cathodic sign is negative sign. So this process is called as a electrolysis process. In the electrolysis process, at the anode, oxidation takes place. In the electrolysis process, at the anode, oxidation takes place. Oxidation means the loss of electrons we are called as a oxidation. Loss of electrons is called as a oxidation. When Cl minus ions, the dissociated of NaCl is converted to Cl minus and Na plus ions. These Cl minus ions, it's converted to lose the electrons, 2 electrons, and converted to chlorine gas. This chlorine gas is liberated at the electrode of anode. At cathode, the reduction takes place. The NaCl dissociated of NF plus ions, sodium plus ions, to gain the 2 electrons, to convert it to sodium. This sodium metal is deposited on the surface of cathodic electrode. So the overall reaction of electrolytic cell, 2 Na plus and Cl minus, and gives rise to 2 Na plus Cl2. This is the overall reaction of electrolytic cell. In the electrolytic cell, electrode, we know that electrolyte is NaCl is the electrolyte. Usually, electrolyte is the conductivity material. The which material is completely dissociated in the aqueous solution, those were considered as the electrolyte solution. Electrolyte. The electrolytes are different types. There is a strong electrolytes is there and weak electrolytes is there. Strong electrolytes means when the substance is completely dissociated, decomposed in the electrolytic solution, aqueous solution, those we are considered as a strong electrolyte. Strong electrolyte is nothing but strong acids act as a strong electrolyte. Strong acids, the best example is HCl, it is a strong acid. HNO3 is a strong acid. And H2SO for sulfuric acid is also act as a strong acid. These are the strong electrolytes. Like salts are act as a strong electrolyte. NaCl, it is a strong electrolyte. KCl, it is a strong electrolyte. Potassium hydroxide is a strong electrolyte. The salts also act as a strong electrolytes. And some of the bases, strong bases also act as a strong electrolytes. For example, sodium hydroxide act as a strong base, strong electrolyte. It is a base, it is a strong base. It acts as a strong electrolyte. Weak electrolytes, which are partially dissociated in the aqueous solution, which are when it's not completely dissociated in the electrolyte solution. So those electrolytes were considered as a weak electrolytes. The best example of weak electrolytes, weak acids. For example, acetic acid, CH3COH. So weak acid, it is weak electrolyte. So due to the reason of electrolysis process, these electrolytes is undergoes to electrolysis process and deposited on the specific metals or electrolyte at the respective electrode to move the respective electrode. So this is the electrolytic principle. So in the electrolytic cell, we are going to discuss, we are going to identify, we are going to quantify certain compounds, how it involves the electrolysis process. That is electrolytic cell. What are the applications of electrolytic cell? If you look at that electrolytic cell, the water, if you take water, the water molecule having H2O. So the water, how it's going to dissociated, electrolysis happened. After electrolysis, what are the product, how they convert to the oxygen gas and hydrogen gas, we are going to discuss, we are going to quantify using of this electrolytic solution. And one more advantage is there, the electrolytic solution, usually we are going to extraction of particular metals. For example, we are extracted of aluminium from bauxite. This is the applications of electrolytic cell. Electrolytic cell is a non-spontaneous oxidation reduction reactions takes place. Non-spontaneous, when the non-spontaneous oxidation reaction is involved, then that reaction is chemical reaction, that is the chemical reaction, it cannot convert it to the electrical energy. So there are so many advantages also there, this electrolytic cell. Now we are going to electrochemical cell. The electrochemical cell is nothing but the chemical energy where it is converted to electrical energy. Those cells we are going to classify electrochemical cells. The chemical energy is converted to electrical energy. Those cells were called electrochemical cells. Then we can say that is galvanic cell. Usually, Daniell cell, it is the best example of galvanic cell. Daniell cell is the best example of galvanic cell. Galvanic cell is nothing but voltaic cell. Galvanic cell is nothing but voltaic cell. This is the first electrochemical cell. So that's the reason we are called as a voltaic cell. Voltaic cell, in the voltaic cell, the spontaneous redox reaction takes place. When the spontaneous redox reaction is involved in the reaction, in the chemical reaction, it can generate the electrical energy. So that electrical energy, because we are going to utilize different applications. So usually spontaneous redox reactions, the delta is G always less than to 0. The delta G means Gibbs free energy. The Gibbs free energy always less than to 0. When the reaction Gibbs free energy is less than to 0, that reaction is spontaneous redox reaction. The spontaneous redox reaction is involved in the voltaic cell. Usually, electrochemical cells are constructed using 2 electrodes is placed in an electrolytic solution. Electrochemical cells are constructed using 2 electrodes and placed in respective electrolytic solution. Every galvanic cell, either voltaic cell, must contain some of the following components. So first one is an oxidation of off cell. The oxidation of off cell means where the electrons will be loose or lost, that is considered as a oxidation of cell. The another part is a reduction of cell, where the electrons will be accepted or gained. That off cell is called as a reduction of cell. With another component, we are going to connect these 2 cells using voltmeter. This voltmeter, it can useful for the measure the potential of this cell. We are going to measure the potential of the cell using this voltmeter. And to complete the electrochemical reaction, cell, we need to use salt bridge. The salt bridge to maintain the charge balance in between the 2 off cells. These are the important components present in the voltaic cell. Galvanic cell. The one is oxidation of cell, and another one is a reduction of cell, and one voltmeter, and another one salt bridge. These are the components present in the electrochemical cell. Look at that electrochemical cell. When we are going to construct the electrochemical cell, that means voltaic cell, there is a 2 off cells is present. The left side off cell is having zinc electrolyte and respective zinc electrode, zinc metallic electrode. And right side, that is a reduction of cell. The reduction of cell we are utilized copper electrolyte, that is copper sulfate electrolyte, and copper electrode. We are immersed in the electrodes in respective electrolytic cells. These are the two off cells is present. These are the two off cells is present in the voltaic cell. Left side of cell and right side of cell. So these two off cells having electrolytic solutions. The electrolyte solutions are zinc sulfate and copper sulfate solutions. And two electrodes, that is zinc electrode and copper electrode. Here the zinc electrode is act as a anode. The sign value of anode in the electrochemical cell, that is a negative. In the sign of the cathode in the electrochemical cell, that is positive. So copper electrode we are represented as a positive. So zinc electrode we are represented as a negative, because zinc is involved to the oxidation takes place. Zinc is involved to the oxidation reactions. So zinc electrode, where the oxidation takes place, that electrode we are called as a zinc electrode. That electrode is an anode electrode. The zinc is act as an anode. Where the reduction takes place, that electrode is act as a cathode. That is cathode electrode. Copper is act as a cathode electrode. These two electrodes were interconnected with voltmeter. These two electrodes is interconnected with voltmeter. This voltmeter is going to measure the potential of in differences between the two off cells. So which potential difference? We are going to measure the potential difference using of this voltmeter. To complete the electrochemical cell, voltaic cell, it's a required salt bridge. To complete the electrochemical cell circuit, voltaic cell, it's required salt bridge. Salt bridge to manage the ions, to manage the ionic charge in between these two off cells. So once we are connected with this salt bridge, then spontaneous redox reaction is thoroughly happened in the voltaic cell. The off cell, the left hand side of the off cell reaction, so there is a zinc electrode to involve oxidation to lose the electrons, because zinc electrode where the oxidation takes place, that zinc electrode to convert the zinc 2 plus ions plus to release the 2 electrons. This zinc 2 plus ions to excess of in the electrolytic solution These 2 electrons to move from anode to cathode. This cathode, this copper sulfate solution, which is electrolyte solution having the copper sulfate, this copper sulfate solution, the dissociated of copper 2 plus ions, to gain the 2 electrons is converted to copper. So zinc is going to oxidation to convert it to release the electrons. These electrons, the copper to gain that electrons, copper 2 plus ions to gain the electrons, to convert it to copper solid. So where the oxidation takes place, that electrode is an anodic electrode. That's why we are called as a zinc as act as an anode electrode. Here zinc is converted to zinc 2 plus and to release the 2 electrons. And the copper to gain the electrons, 2 electrons, to convert it to copper solid. This copper solid is deposited on the surface of the copper electrode. So this is through this redox reaction, so the potential is generated and the specific of cells. The difference in between the potential differences in between the off cells of anodic off cells and cathodic off cells, we are going to measure using of this voltammeter. And salt bridge to neutralize the excess of zinc plus ions and copper plus ions or sulfate ions and in the electrolytic solution in the off cells. So salt bridge is required to complete the electrochemical reaction. So what is the overall reaction? We know that overall reaction at anode, the zinc is converted to the zinc's electrode to lose the electrons to convert it to zinc 2 plus ions and to release the electrons, 2 electrons. At anode, the zinc is going to release the electrons. At cathode, the copper 2 plus ions to gain these 2 electrons is converted to copper solid. And we know that the overall reaction zinc solid plus copper 2 plus ions and zinc 2 plus and copper solid. So zinc is involved to the oxidation and copper is involved to the reduction. So this is the overall reaction. So zinc solid plus copper 2 plus gives us to zinc 2 plus plus copper solid. They are represented by Voltaic cell, usually zinc and zinc 2 plus slash zinc 2 plus, double slash is represented by salt bridge, and copper 2 plus and slash and copper. So it depends on the potential, the concentration of zinc 2 plus ions, the concentration of zinc 2 plus ions and copper 2 plus ions. The concentration of zinc 2 plus ions and copper 2 plus ions, the potential is generated in the Voltaic cell. And what is the advantage of salt bridge in the Voltaic cell? The salt bridge, to complete the electrical circuit, to complete the electrochemical circuit and allows the ions to flow through the both off cells. It can allow only ions. When to allow the ions, the potential cannot generated in the salt bridge. So that's the reason it's required non-reactant electrolyte in the salt bridge. So the salt bridge, usually 2 types of salt bridge we are using in the electrochemical cells. Glass made bridge, and some of the investigators, they are using filter paper bridge. Glass tube bridge, they are using U-shaped tube and filled with agar-agar gel along with electrolytes. The electrolytes are, usually they are using KCl, NaCl and potassium nitrate. This KCl, NaCl, potassium nitrates, it cannot interact with in the cell electrolytes. And that's the reason we are using this type of salts in the agar-agar gel, salt bridge. These are the unreacted with other chemicals in the cell. And one more type of salt bridge, that is a filter paper bridge. Commonly, we are used porous material or filter paper soaked, electrolyte soaked filter paper, we are using as a salt bridge. So the porous material, also porous material paper or filter paper, we are soaked with electrolytes, then we are utilized as a salt bridge in the Voltaic cell. So when we are soaked, after soaking of electrolytes, that filter paper, it acts as the porous paper or porous membrane, it acts as a salt bridge. It can neutralize the ions in the electrochemical cell. So in the salt bridge, maintains the electrical neutrality by allowing excess of zinc ions to enter from anode and excess of negative ions to enter from the cathode. So the excess of zinc 2 plus ions and negative ions, it's going to manage, it's going to neutralize using of this salt bridge. These are the advantages of salt bridge. And usually Voltaic cell potential is 1.1 volts. Now, what are the main differences in between the Voltaic and electrolytic cell? What are the differences in between the Voltaic and electrolytic cell? Electrochemical cell is nothing but Voltaic cell. Electrochemical cell is nothing but Voltaic cell. It is the electrochemical cell or galvanic cell, we are called as a galvanic cell. And another cell is electrolyte cell. What we are discussing in the topic, that first cell is electrolytic cell, another one is electrochemical cell. In the electrochemical cell, chemical energy is converted to electrical energy. The chemical energy is converted to electrical energy. So that is electrochemical cell. We know that the differences, the first differences is where the energy is released through the chemical reaction, we are considered that is electrochemical cell. In the electrolytic cell, the electrical energy we are going to utilize and it is going to convert chemical energy. That means utilization of electrical energy, we are going to discuss, we are going to quantify the chemical reaction. So that is electrolytic cell. So usually in the cell, in the electrochemical cell, the anode we are going to represented by negative sign. And similarly, cathode is we are going to represented by positive sign. So in the cell, in the electrochemical cell, anode is a negative and cathode is a positive sign. But in electrolytic cell, anode is a positive and cathode is a negative sign. So in the electrolytic cell, anode is a positive and cathode is a negative sign. If you go for electrochemical cell, it's a required salt bridge. Otherwise, the potential is imbalanced. We are not getting the proper potentials in the electrochemical cell. It's a required salt bridge to complete the electrochemical construction. But in the electrolytic cell, the salt bridge is not required because directly the electrolyte is going to dissociate it and it move to opposite sign of the electrode. That's the reason the salt bridge is not required in the electrolytic cell. So, and another difference is processes, the electrochemical process is irreversible process. And it also spontaneous reaction, redox reaction is involved. So in the electrochemical cell, it is a reversible reaction. The process is a reversible reaction and the spontaneous redox reaction is involved. But in the electrolytic cell, the process is irreversible and the reaction is non-spontaneous reaction. Non-spontaneous reaction. So that's the main differences in between the electrochemical cell and electrolytic cell. The EMF of the cell is a positive always in electrochemical cell. EMF means that is electromotive force. The cell potential is always positive value. When the cell potential always positive value, then we can say that that is electrochemical cell. The EMF of the cell in the electrolytic cell is a negative potential. The potential, the EMF of the cell is always negative in the electrolytic cell. In the electrolytic cell, the potential difference is always negative potential. When we see that negative potential, then we can identify that is electrolytic cell. When we are getting positive potential, that is electrochemical cell, that is galvanic cell. Usually, the delta Z is less than to 0. The Gibbs free energy, when less than to 0, then we can identify that is electrochemical cell. It means spontaneous redox reaction is involved. In the electrolytic cell, the delta Z is greater than to 0. That means it is a non-spontaneous reaction. When the non-spontaneous reaction is involved to the electrolytic cell, then we can say that is electrolytic cell. These are the main differences in between the electrochemical cell and electrolytic cell. And thank you.
Like, share and subscribe. Hit the bell icon for more updates.